Hi everybody, good afternoon. The TryHackMe released the new room yesterday, late. No, I think at night. I didn't see it. React2Shell CVE 2025-55182. This is very dangerous. If you heard the news of IT, everybody's talking about it. It is explore the CVE 2025-55182 vulnerability in React Server component. This is like a perfect 10. No authentication, nothing. You can just access the server, get reverse share and everything. So in this task, this is a free room. I think everybody can check it. It's a room info. This is a free room. You can try it. In this task, we will explore CVE 2025-55182, one of the most critical vulnerability discovered December 2025 with a maximum CVE SSS score of 10. This vulnerability affects React Server component RSC and framework that implement them, particularly Next.js. The vulnerability doubled React2Shell by researcher allow an authenticated remote code execution through a single crafted HTTP request. Here we'll examine the technical foundation of this flow, understand how React Flight protocol work, analyze the actual exploitation chain, and dissect a working proof of concept that demonstrate to you what remote code execution. By the end of the task, we'll comprehend how a seemingly innocuous deserialization flow can cascade into full system compromise. Here, of course, the official they have two official. That's a Facebook. Why? It's a Facebook CVE in Facebook. Uh, Critical security vulnerability React server. This is the React website, so we have the information when they declare it. There is an authentication remote code execution. Now let's follow here. So before we dive, okay, the vulnerability version is 19.0, 19.1.0, 19.1.1, 19.2.0. Span the following React Server DOM Webpack and the Server DOM Parcel and DOM Turbo Pack. To protect, you need to upgrade to 19.01, 19.1.2 or 19.2.1. So basically, this is the room. Of course, we'll do now. There's a lab. We have a React vulnerable React application. It is a hello world, a simple application running 3000 port. We come back to this now. Now, the next one, task 2, is extending a React Server component and flight protocol. Now, before we can grasp the vulnerability, we need to extend the architect of React Server component. React Server component is a feature introduced in React 19 that allow component to be rendered on the server rather than the client, which means make it more server significant performance benefit. And in the server can handle computation intensive tasks while sending only rendered output to the client. Now, the communication between the server and the client RSC relies on protocol called React Flight. This protocol handles the serialization and deserialization of data being transmitted between the server and client. When the client needs to invoke the server-side function called server action, it sends specially formatted requests containing serialized data that the server deserializes and processes. The flight protocol uses specific serialization format. We have this $@ denote the chunk preference and $B denote the blob reference. Reference can include property path using colon separation. That's where the problem comes in later on. The serialization mechanism is where the vulnerability lies. The server processes this reference without properly validating that the requested property are legitimate export. Now, for example, first question, what is the symbol that denotes the blob reference? The blob reference is $B. So you can go this one, so you can go straight to the lab, so you can understand some. Now, the task 3, the core vulnerability Unsafe deserialization. So, is vulnerability Unsafe deserialization vulnerability is how React Server component handle incoming flight protocol payload. Vulnerability exists in the require model function with the React Server DOM Webpack package. So you have the function. Now this is where the whole thing's in the data, the metadata. this model export metadata is in JavaScript. We access, basically you can the problem is for example here is think of it a way that for hacker to trick the server into running malicious command. The co-plunderer is a simple term. Imagine you have a vendor machine, the server that's supposed to only dispose specific item you request. Normal operation is so give me item 5, the machine give you item 5, then the empty you say give me item number 5, then go to the constructor, then go to the constructor again. Now you can access the machine control panel and make it to do anything. And the variant to JavaScript is model export metadata to. That's why the danger will come in. So if we follow for TryHackMe here, it's talk the constructor. That's where the whole things is. An attacker obtains a reference to the global function constructor, which can execute RBD JavaScript code when invoked with a string argument. So basically you have it like that. So get chunk model 1, access its constructor properly, get the function constructor, access the constructor again, and something. This is we do the lab will be clearer later on. Now next one is the exploitation chain from deserialization to remote code. The proof of concept in this room is using this one. This is the guy that pushed the link here. You can see we can see the constructor exactly. Where is it? This one. For example, is using open a calculator. You can see that one. So the constructor execute a calculator and not a child process. We will come back to this when we do the lab. Achieve remote code execution. The exploit cleverly chain together multiple JavaScript engine behavior to transform a deserialization bug into arbitrary code execution, creating a fake chunk object. So the exploit begins by sending multiple form requests with 3 fields. The first field contains carefully crafted fake chunk object. So the object mimic React internal chunk class structure by setting then to reference a chunk prototype. Then we create a self-referential structure. When React process this and wait for chunk, it invoke then method with a fake chunk as a context this. So basically then we go to the calculator command. Explode the blob deserialization handler. The second critical component is the $B. Handler reference B1337. React flight protocol. The $B prefix indicates a blob reference. When React processes a blob reference, it calls a function that entails use a response format get response ID. Here, where the exploitation became elegant, we have polluted the response object with a malicious property, and then it actually executes this, and then we have our calculator process there. Let's break down. For example, we set format.get to point to one constructor which resolve the function constructor. The prefix contain our malicious code. When these are combined, the function constructor is invoked with our code as a string argument, creating and amplifying, implicitly executing a function containing our arbitrary JavaScript. Now we have the payload. For example, now to demonstrate the power of this exploit, we are using Node.js model system to access the process main model. Use it required method to load the child process. Call existing to execute an operating system command, and then in the case we have a calculator. Let's now analyze the proof of concept, and then we have the exploitation. This is the analyze the process of concept. This one, remember we came here. Where is it now? This one. So we have a log source within the chunk data layer. The next action had a trigger React server action processing. The multi-part body contains 3 part. Field 0, we have where that one, the response, where is it? Response extracted the feed 1 reference at $@0 that point back to feed 0, creating a self reference. Feed 2 an empty array completing the required structure. So we have how many we have? We have 1, 2, 3 the array, and then the empty, and then the first response. Now, the vulnerability evasion attack surface React 19.00.10.11 and 19.2.0 next version greater than 4.3 Canary, all 15 and all 16 release prior patching. All the framework using RC, React, Router, CS Mod, Wuku, Redwood SDK, and various RSC plugins. The vulnerability is particularly dangerous because default configurations are vulnerable. A standard Next.js application created with CreateNext app is exploited without any code change, no authentication required, high reliability, wide deployment. Now, I'll tell you, with research data shows 39% of a cloud environment contain vulnerable instance. According to Schunen, more 500,000 public server utilize React component, and almost 500,000 use Next. So now let's go to the lab. Now you can see the lab they give us all. They tell us, oh, see, we start the application. So we have our application. Where is our lab? This is our lab. We have this simple application, hello world. You can see it's a hello world. Did they start burp? Let me start burp so you can see what's going on. How come I didn't start burp? I was busy with doing something else. I was doing another room of TryHackMe. I was doing this room. I thought to do a quick let's go back before things start. So we have, this is the payload we'll use, targeting the 3000 port. There wasn't working the update in the room. There was in morning it said you bad request, but they fixed that problem this morning. As you have learned through the previous task, you can spot from XID. So for example, here we have our application execute ID. That's why we put our command there. So they tell us how to do it. Let's start our burp suite. Start, my friend, burp. Okay, we just copy it and paste it. Of course, we need to change the machine IP. We have target is 10.49.1.4.25. So let me copy. Let me start. I was supposed to start this before. Sorry, guys. Let me make it bigger. So we have now our burp. Let's go to repeater. We can where is it? Let's catch something. Let's catch first of all this one. It's a React, this one. So let's do that. Refresh the page. So we have this. That's a normal the normal one. That's the reacted. What happened here? Why is it not found? Is redirecting or something. In any case, where is that? Let's copy that code we have here. We can paste here from TryHackMe, copy and paste. We can add another HTTP request. We can paste it there. We can leave everything as it is there. So we have our code, the 3 stages. We have our command ID, one is that one, and then we need to edit that one. The machine IP is not that one. The port is 3000. What was the machine IP? Let me stop this one. I don't need it. Oh, that's the machine IP. Let's go to our friend burp. The host now is that one. We have port is 3000. So we're following the steps of the room. So we have that one. You do that, you add the port machine, you do this thing, the port machine there, and then let's try to see if it's work. Press OK. Let's press there now, and then we got ID username Ubuntu. So if I change it, for example, now to ls-la, for example, now I can get the ls data. In TryHackMe they put the example of let me remove that ls date, for example. If you want to check the date time in the machine, so we have Saturday. So we've been able to execute in the machine here. This is an example of TryHackMe. Let's do simple things and see. They tell us what's the name of the user running the vulnerability. We already did that, but let's try a date. We can say who am I, and we have it's Ubuntu the user, so we can go there, Ubuntu. And then we have instead of flag in the etc file, so we can say cat etc flag.txt. I'm typing it in to reduce stress. So we have a file, so we got the flag. Now let's try to do a reverse shell, for example. Let's let's do reverse shell. Let's go to reverse shell generator. The IP, my it is on 901. My IP is 10. The attack box 1049.93.67. So we can use, for example, this NCMQ. Let's use this one. Let me zoom it so everybody can see. So we'll use this one. I'll put my NC in 9001. NC minus LVNP 9001. No. 9001. Then I can go to burp. I test it. Let's see if it works. So remove that cat there. If I put that things there, the shell, let's see if it does work. It should work because you can see the freeze, and then we hot ID. Then what happened? Who am I? And Ubuntu, I can do now, go to etc, and I can just cut the flag there, the txt, and we are 19 reactive 19.201. Of course you can go all of that. So Ubuntu is there, no, it's React is running somewhere else. So basically that's the proof of concept. Even you can get a reverse shell if you want. Now a detection, of course, now this portion of the room will provide various detection mechanism. For example, Fountain has defended the specific vulnerability require interactive with React and React Server component RCA with a specific format and structure. Regular user browsing activity will not have specific header and value within HTTPS. For example, the next action and multi-platform data are incredibly specific query and payload for React Server Combat Flight Protocol. So we have the next action header, multi-platform data, element window form data with element such status, reserved model. Then we have then $1 proto. Then so we can detect this one, Snore version 3. So you have this detection mechanism for it. Then we have at summary this note: listen to the specific header within requests that aren't usually generated by the regular user traffic. Determine multi-platform data where RCSC do not really use, and then name equals basically more technical stand. Then OS query, we can use a following, for example, for detection. This room is free, guys. If you want them, you can just access the room. As a summary, this detective vulnerable package are used within endpoint, React Server DOM Parser, React Server DOM Turbo Pack, React Server DOM Webpack, and all of that. The benefit of this query rule that we can search and determine for vulnerability varies across endpoint. Yeah, guys, so I hope you like it. You can practice. I read many things. There's What's this one? Now that you have come to this far, it is essential for that you refrain from attempting such penetration tests against any system without explicit permission, a written agreement. The primary purpose of this room is to allow you to experiment in safe laboratory environment without violating any laws. We have provided you with the one POC, however it is up to you to experiment with other exploit codes. When we set out to create the room about this CVE, the number of incorrect people, there was a lot of incorrect I was reading as, which one, what link is this, TryHackMe? Put it, anything that require a developer to have explicitly exposed danger functionality to the client is not a valid POC. In fact, we wasted a non-trivial amount of time dealing with a POC. React2Shell, they create a website already. Things get funny when the bundle app remain exploitable despite upgrading to the Venator library. In other words, there are many POC online that work with their bundle app. However, they are not real POC, and bundle app is broken. Continue to allow things it should not despite switching to patch version. So yeah, moreover, we can confirm that once we follow the recommendation of npm audit, the exploit is no longer works. Our goal is to offer the most authentic laboratory experience for our user. So remember, upgrade and yeah. So yeah. Thank you everybody. Thank you very much. You can check the lab if you want, and as they said, be safe. What's this one? Update proof of concept. A real public begins safety after 30 days. I have now shared a POC file later for write-up during course. Which one? This one is, I'm not sure if this one, we didn't test this one. In any case, thank you very much everybody and have a good day.